In this next video, I'd like to have a look at how to find the distance between 2 points. Now, of course, if you draw it, you can calculate it using Pythagoras, but we have what you would call a coordinate geometry equivalent of Pythagoras, and it's this here, where we say the distance is equal to the difference between the two x values squared and the difference between the two y values squared. And so if we were to choose, for example, any one of these, and I'll just choose this one here. This is 2, 1, and 4, 4. So let's have a look. I'm going to draw that one up. Here we go. So got our graph, 2 along, 1 up. Call that 2, 1 there. 2, 1, and 4, 4. We'll call that 4, and we'll call that 4. Here we go. So that's 4, 4. And if you wanted to find the distance between those 2 points, we could do that using this formula. So the first thing I'm going to do is to designate either these as x1, x2, or y1, y2. So this one here I'm going to call x1. Doesn't matter which one I call x1. And this is going to be my x2. So let's start to populate this thing here with that information. So here we go. We've got d is equal to x2 minus x1. So x2, that's going to be 4 minus 2. So I'll write 4 minus 2 all squared plus, now we're going to have y2 minus y1. So y2, I'm going to call this y2. I'm going to call this one on the side y1. So y2 is going to be 4 minus 1. Here we go. So 4 minus 1 all squared. Of course, it's going to be the square root of all of that. So we can do this a bit quicker now. Well, 4 minus 2 is 2. 2 squared is 4. Plus 4 minus 1 is 3. 3 squared is 9. Now, of course, 4 and 9 is 13. So it's going to be, the distance is going to be root 13. If you wanted to put that, you could just leave it as root 13, but I'm going to actually find what that is. So I'm just going to go square root of 13, and we get 3.6. I'm going to call that 3.61. Is equal to 3.61. And we don't know, there's no actual units here, so I'm just going to call it units. There it is. 3 points, that's what could be, isn't it? Call that a 6. 3.61 units. So the distance here is going to be 3.61, and that's the distance from one end to the other. All right, so that's essentially the way in which we do that. Lots of other variations that we can do, of course. Probably a classic is when we know the distance and we've got to find one of the coordinates. But nonetheless, that's the basis of what you need to be able to do. Let's just do one more just for a little bit of fun. So let's choose another one here. In this case, I'm going to go, let's have a look, -2, 5, -4, -1. So they have a whole bunch of negatives. Here we go. So in this case, I've got, I'll write down my two coordinates. I've got, let's see, I've got -2, 5, and I've got -4, -1. Here we go. So I'm going to find the distance between those two. So the distance is going to equal, and I'll write my formula first. That we've got something which we can work with. We've got an x2 minus an x1, all squared, plus we've got a y2 minus a y1, all squared again, is equal to, and this time I'm going to go ahead and write these in first. So this is going to be my x1, it's going to be my x2. So I've got -4 minus -2. That's going to be all squared plus y2, or y2 is going to be this one here, y2, y1. So I've got -1 minus y1, which is 5. And that's, again, all squared. Square root of all that. So a little bit more work to do this time. So -4 minus -2. So this is really -4 plus 2, which is the square root of -2. Now, sorry, the square of -2. So -2 squared is going to be 4 plus -5 minus -1 minus 5 is -6. -6 squared is going to be 36. So we've got is equal to 40, square root of 40. And again, we could just leave that as root 40, but probably best to find out what that is. And I don't know what that is just offhand. Let's find it if we can. Square root of 40 is, I'm going to call that 6.32. 6.32, and it would be units. Obviously, if it gives actual, we know what the units are, like they're centimeters or meters or kilometers or something, we can write that in. Otherwise, that's how you'll do that.